Welcome to The Explainer. Today, we are unpacking a fascinating and honestly pretty urgent study that recently dropped in the journal PLOS One. We're looking at the severe future climate risks facing one of the world's absolute biggest economic engines, Shanghai. Seriously, if a shipping and financial hub of this scale ends up underwater, the entire global supply chain goes right down with it. So let's dive into the multi-case simulation researchers built to see exactly what happens to this megacity over the next few decades. Spoiler alert, the results are incredibly revealing. It's a question that kind of sounds like the plot of a sci-fi disaster movie, right? But for Shanghai, it's a very real existential threat. Think about it. How does a massive global financial, trade, and shipping hub survive when the ocean is relentlessly pushing up and the very ground it's built on is literally sinking down? Well, let's figure this out, because understanding this dynamic, it's absolutely crucial, not just for Shanghai, but for coastal cities all over the globe. To tackle that question, the researchers modeled what they call a layered triple threat. See, instead of just looking at climate change as one giant vague problem, they broke it down into three specific hazards, layering them on one by one. Case 1 looks strictly at global sea level rise. Then, Case 2 adds local land subsidence, which is basically the city sinking, into the mix. And finally, Case 3 throws in the absolute chaos of extreme storm surges. By layering these on top of each other, we really get to see how these factors interact to create a rapidly escalating disaster. So let's start with Threat 1, sea levels. This first baseline threat is driven entirely by global ocean expansion and melting ice sheets. And utilizing IPCC projection data under a mid-range emission scenario, the numbers for Shanghai are pretty eye-opening. By 2050, we're looking at a 0.32-meter rise. By 2070, it's nearly half a meter. And by 2100, we're looking at a baseline global sea level rise of 0.81 meters. Now, when you remember that Shanghai sits on a very flat plain with an average elevation of just over 2 meters, yeah, that 0.81 meters suddenly becomes incredibly daunting. So what does a 0.81 meter rise actually look like for the city on the ground? Well, if global sea level rise was the absolute only factor at play here, Shanghai would permanently lose over 361 square kilometers of land to flooding by the year 2100. To put that into perspective for a second, that is like permanently flooding an area larger than the entire city limits of Atlanta. It's a massive, steady erosion of the coastline. But as we know, sea level rise doesn't just happen in a vacuum. And that brings us to a really crucial concept for this explainer: relative sea level rise. You see, this isn't just about the ocean getting higher, it's about the synergistic effect of global ocean levels rising while the localized land surfaces sink at the exact same time. It's basically like pouring water into a bowl while simultaneously lowering the bottom of the bowl. Which brings us to the bottom of the bowl. Threat 2, land subsidence. So we need to shift our focus from the global climate to the actual ground beneath the city itself, the second layer of our triple threat. Why is Shanghai sinking in the first place? Well, it's a highly localized, human-driven phenomenon. Over the decades, excessive groundwater extraction has heavily depleted the aquifers beneath the city. You combine that with the natural compression of Shanghai's super soft soil foundations, and then, get this, add the immense, literal, physical weight of rapid urbanization. We're talking thousands of massive skyscrapers and infrastructure networks. The ground is just physically compressing under it all. So we are actively compounding a global climate problem with local human activity. And when we actually run the numbers for the year 2100, the reality really sets in. We take our global sea level rise of 0.81 meters and we add the cumulative land subsidence. Using some intense time series modeling of local geological data, the researchers project the land is going to sink an additional 0.43 meters by 2100. Add those two together, and the total relative sea level rise jumps to a perilous 1.24 meters. Guys, that is way, way beyond the global average. And the real-world impact of that extra 0.43 meters of sinking is severe. When we add subsidence to the equation, the 2100 inundation zone leaps from 361 square kilometers straight up to nearly 461 square kilometers. That is roughly a 28% increase in flooded land, strictly due to the city sinking beneath its own weight and water usage. All right, on to the final layer. Threat 3, storm surges. This introduces the absolute most chaotic layer to the study: extreme weather. The researchers make a really vital observation here, stating that the combined effect of these factors is not simply linear, but exhibits a nonlinear amplification effect. Now, what does that actually mean for us? It means 1 plus 1 plus 1 does not equal 3 in this scenario. Because the land is lower and the baseline sea level is higher, when a storm surge hits, the natural coastal buffers are just gone. These hazards literally multiply each other's destructive power. When we map out that nonlinear amplification, it hits like a massive shockwave. Remember, case 1 gave us 361 square kilometers of flooding. Case 2 bumped it to 460, but the moment an extreme storm surge is added to this sunken, elevated sea level environment in case 3, the inundation area absolutely skyrockets to 1,331.91 square kilometers. That is a staggering 870 square kilometer jump, simply because a storm surge hit an already compromised coastline. As we project toward the end of the century, this third storm surge scenario completely dwarfs the first two baseline threats. It doesn't just climb. It hovers at this catastrophic level compared to the steady baselines below it. It really proves that extreme, unpredictable weather events are going to be the ultimate driver of disaster in Shanghai's future. Now, let's talk about unequal urban risk distribution. It's incredibly important to note here that this massive influx of water, it won't behave like a bathtub filling up evenly. The researchers found stark spatial heterogeneity, which, is just a fancy academic way of saying the risk is highly unequal depending on your zip code. On one hand, you have these highly vulnerable coastal zones like Chongming, Pudong, and Baoshan. These areas sit on soft soil, they have high rates of subsidence from industrial activity, and they face massive inundation. But on the flip side, inland districts like Jing'an and Hongpu sit on slightly more elevated terrain, they have much slower subsidence rates, and they show virtually zero projected permanent inundation in these models. So the disaster is highly, highly localized. To put that inequality into perspective, under the worst-case storm surge scenario in 2100, Chongming District alone absorbs over 54% of the city's total flooded area. That's over 725 square kilometers just in one district. And this is a massive blow, particularly because Chongming Island is an ecologically vital area. It houses these globally important wetlands that serve as critical stopovers for migratory birds. And the real-world consequences of all this compounding water pressure are vast. We aren't just talking about wet ground here. We are looking at existing seawalls, some of which were designed 50 years ago, facing complete structural failure under pressures they were never, ever built for. We're looking at deep underground metro tunnels in Pudong, literally deforming as the soft soil sinks and shifts around them. Plus, there's the severe salinization of those vital wetlands on Chongming, and the potential for hundreds of billions in financial losses as coastal industrial parks and logistics hubs are compromised. It's the whole shebang. So, how do we fix this? Let's look at building future climate resilience. Knowing all this, how does a massive megacity actually adapt? Well, the study lays out several essential steps. First, Shanghai has to strictly regulate groundwater extraction to slow down the subsidence. This is crucial because it's the one factor completely within our local control. Second, coastal flood defenses and tidal barriers must be upgraded way beyond their historical thresholds to handle that 1.24-meter relative rise we talked about. Third, land use planning needs to be optimized. Basically, keep critical new infrastructure out of those high-risk coastal zones. And finally, the city absolutely must enhance its extreme weather early warning systems to prepare for those massive nonlinear storm surges. If there is one core takeaway you get from this incredibly detailed research, let it be this. Sea level rise, land subsidence, and storm surges do not act alone. Together, they create a synergistic mechanism of disaster. 1 plus 1 plus 1 equals a catastrophic multiplier that can easily overwhelm even the most developed infrastructure if we're only planning for a single threat at a time. Which leaves us with a final, very pressing thought. Shanghai is mapping this out with incredible precision right now. But what about the rest of the world? Are other global, coastal megacities blindly ignoring this exact same layered climate risk? Or are they truly prepared for the compounding triple threat happening beneath their feet and off their shores? Thank you so much for joining me for this explainer. Until next time, keep looking beneath the surface.